So moving on from the discriminant session that we've just had, we are looking at the discriminant which comes from picking terms from a quadratic. This is our quadratic here. And we're picking b squared minus 4ac from our quadratic to determine how many solutions a quadratic equation would have. So we're going to look at an example. This is a question from a WJEC paper. It's from the specimen paper, so we're going to look at how it asks and how there's many ways of asking questions regarding the discriminant. It gives you a quadratic equation 4x squared minus 12x plus m, and it tells you that m is a positive constant. It tells you it has two distinct real solutions, so that's the important bit for us, okay, that we highlight that it has two solutions. Now, instantly we should be thinking about the discriminant, okay, because remember earlier we said that there's three possible outcomes. B squared minus 4ac greater than 0 will give you two solutions, two real solutions, two distinct solutions, lots of ways of saying the same thing. B squared minus 4ac is equal to 0. This is one solution, one real root, repeated root. Repeated root just means two of the same. And then you have b squared minus 4ac is less than 0, which means that we have no real roots or no solutions. Okay, so looking at this question, as soon as it says that we have two distinct roots, I am looking at this bit, or I'm thinking about it. Let's see how we can put it into the question. Show that the quadratic equation 3x squared plus mx plus 7 equals to 0 has no real roots. Okay, so we take a minute to think about it. There are two different equations at the moment. The first one is 4x squared minus 12x plus m, and the second one is 3x squared plus mx plus 7. So it's hard to see what the link is really between the two, but you will see that they both have a constant m here. So if we are able to calculate the m value from the first equation, we are able to then put it into the second equation and work out and convince ourselves that there are no real roots for the second equation. So let's start with the first equation and see the facts that we have been given. So we've got 4x squared minus 12x plus m, and it tells you a little bit about this equation. It tells you that it has two solutions, two real roots. Okay, so it's got all the x's in it. The only thing missing is the c value or the m value here. I'm going to bring out my discriminant and I'm going to say for two real roots, b squared minus 4ac needs to be greater than 0 for two solutions. Now, we pick our a, b, and c. Now remember that the a, b, and c come from this form, ax squared plus bx plus c, because that's your quadratic equation. So this is my a, b, and c. Compare that with the equation that we have. This will be my a, this will be my b, and this will be my c. So let's put that all in. My b will be minus 12 squared minus 4. A is 4 again, and c is going to be m. And I want to say that this is greater than 0. So we're squaring minus 12 squared. Remember, any negative number squared will just give you a positive. So that becomes plus, and 12 squared is 144. Minus, you can leave the 4 out first and just work these two brackets out first. Multiplied by 4, I'm greater than 0. 144 minus 16m is greater than 0. Just got to rearrange this inequality. I have 144 is greater than 16m. And finally, we can say that 144 divided by 16 is greater than m. So we'll just say that 9 is greater than m, or m is less than 9. So we work out what the value for m is, or the potential values for less than m. So we're going to say that m, and let's put it this way just because it's easier to understand, m is all values less than 9. Okay, let's look at the second part. Okay, so we've worked out what m is. It says show that the quadratic equation 3x squared plus mx plus 7 equals to 0 has no real roots. So if I just do that here. So I'm working with this equation 3x squared plus mx plus 7 equals to 0 has no real roots. Now remember that we're saying that m is all values less than 9. So we can say here m could be 8, 7, 6, 5, and all negative numbers. Now here's the thing. I've worked out that m is less than 9. okay, but I don't know which m will make this equation have no real roots, okay? So I need to work out what makes this equation have no real roots. Now, let's look at this equation for a second. If we apply b squared minus 4ac here, we can use our b squared. So we've got m squared minus 4 times 3 times 7. So this gives us m squared is minus 4 times 21, which gives you m squared equals to m squared minus 84. Right, so here's what we worked out. We worked out that the discriminant b squared minus 4ac is equal to m squared minus 84 for this equation. However, from the previous part, we've also worked out that m is less than 9. So we can actually substitute all values less than 9 here to work out what kind of value we get out for the discriminant. Now think about it. If I do m squared here, we get an answer, so we're squaring the other side as well, we get 81. So if m is less than 9, then m squared is less than 81. So we can put all values less than 81 here in this m here. And what would happen if you put 81 or all values less than 81? You are always going to get a negative answer out, okay? So if you put in m squared 81 or less, hypothetically, if I put 81 minus 84, I get an answer of minus 3. Now, if you get a discriminant value of minus 3, therefore you can say b squared minus 4ac is equal to minus 3. You now have to evaluate what that means. So if I get a negative answer, anything less than 0, we are saying that there are no real roots. So we've actually just answered the question here because it will show that the quadratic, this value, has no real roots, and we've convinced them. We've said actually, depending on m being less than 9, no matter any value of m that we put that's less than 9 into this equation, into the discriminant of this equation, you will always get a negative answer. Therefore, you can say that as b squared minus 4ac is less than 0, this equation 3x squared plus mx plus 7 has no real roots. So this is actually not the most straightforward quadratic discriminant question. There's some very straightforward ones, but there's a variety of questions out there in the exams. Have a go and ask me questions if you're stuck on any. Good luck.